I'm through with sanitizing my hands. I hope you're also doing the same. Wash your hands as many times as possible. We need to join hands, kick coronavirus out of Uganda. The same way we kicked Ebola and polio out of the same country. So let's join hands with the Ministry of Education and Government of Uganda. Ministry of Health and Government of Uganda. Then, viewers, we'll come back from that short break. Obonyo Kenneth once again. We are still dealing with our question. A three-dimensional shape known as a right pyramid. But this right pyramid, the examiner presented us question number 2, or part B, that go ahead and calculate the angle between the slanting what? The slanting face VBC, and the base. Mr. Examiner, sir, before I go any further, according to one of the rules and regulations of three-dimensional geometry, according to one of the laws of three-dimensional geometry, you can be able to get the angle between one line and another line. You can be able to get the angle between a line and a plane, and you can be able to get the angle between a plane and a plane. The examiner has brought us the third category. The examiner wants us to find the angle between one plane and another plane. But the rule states that whenever you're looking for the angle between one plane and another plane, always start by asking yourself or identifying the point where those two planes meet. I repeat, whenever you're looking for the angle between one plane and another plane, start by asking yourself, where do those two planes meet? The point where those two planes meet must be a straight line. Now let me ask you viewers, where does the plane VBC and the plane ABCD meet? Where do those two planes meet? One of the viewers from Mbari is telling me on line AD. No, it is not on line AD. Someone is telling me line AB. Is it line AB? No, it cannot be line AB. We are looking for the line where the plane VBC and the plane ABCD meet. Wonderful. Someone has given us the right answer. Someone has told us those two planes meet on the line BC. Wonderful. They meet on the line BC. Now, after looking at law number 1, which says that if you want to find the angle between one plane and another plane, ask yourself the line where the two planes meet. We have now gotten the line where the two planes meet. That is line BC. We now ask ourselves, the rule goes ahead and says, draw perpendicular bisectors through each one of the two planes. Draw perpendicular bisectors through each one of the two planes. Remember, a perpendicular bisector is a straight line which divides one plane into two equal parts. Now we are going to use our ruler. We get our ruler. We come to the first plane. The first plane is VBC. We are going to cut it into two equal parts. We are going to draw a straight line from point V downwards. That straight line which cuts that plane into two equal parts is what we call a perpendicular bisector. So we come here. We want to draw a perpendicular bisector. Testing 1, 2. Yes. We have a perpendicular bisector. A perpendicular bisector. Our perpendicular what? Bisector. The whole class, it is a what? A perpendicular bisector. We have drawn a perpendicular bisector, dividing plane VBC into two equal parts. But again, we also need to draw a perpendicular bisector, dividing the plane ABCD. But we have to make sure that those two perpendicular bisectors meet at a certain point. I will not draw the perpendicular bisector like this because they will not meet with the first one. I will instead come and draw it like this. So, what am I going to do? Mr. Examiner, sir, I come here, I draw another perpendicular bisector like this. In drawing the perpendicular bisector, that is how it will look like. A perpendicular bisector, Mr. Examiner, sir, through the base plane. Through the what? The base plane. That is what I have. Rule number 2 says, draw 2 perpendicular bisectors through each one of the 2 planes and make sure that the 2 perpendicular bisectors meet at a certain point. Do these 2 perpendicular bisectors meet? Can someone tell us where they meet? Someone is telling me at point O. No, it cannot be at point O. Do they meet at point O? Someone is saying at point V. No, not at point V. You can all see that the 2 meet at that point there. We can even call that point K. Let the meeting point be point what? Point K. The point where the 2 perpendicular bisectors meet is the point where we find the angle that we are looking for. Now, Mr. Examiner, sir, our angle is located here. But remember, the Greeks gave us a very simple format of having angles whose values we don't know. And those symbols, we can have them here. We can have, there is that symbol there known as alpha. There is that symbol there known as beta. There is that symbol there known as lambda. There is that symbol there known as theta. There is that symbol there known as phi. As if that is not enough, there is that symbol there known as mu. All of these are symbols that can be used to represent angles whose values we don't know. The whole class, alpha, beta, lambda. Then this one, theta. Good. Phi. Mu. Mu. Phi. Theta. Lambda. Beta. Alpha. Of course, we are not going to use all of them. We only need just one. We can choose any. Most of you, you're used to theta. It's okay. We can use theta. We can say this is our angle theta. But now, even if we don't have this line continue up to the end point, our interest is for it to just come up to point O. So that we construct a right angle triangle, V, O, K. Remember, we have a 90 degrees there, V, O, K. So we can tell the examiner, from triangle V, O, K, how does it look like? This is triangle VOK. Yes, 90 degrees, V, O, and then K. Do we know the perpendicular height? We knew it as what? What was it? What was our perpendicular height OV? Someone who wrote it down. As we are looking for it, our theta is here. That is our theta. Good. And then we have this length here, OK. Remember, from this point to that point is the same as from this point to that point. That is 8 centimeters. But now this is halfway. This is a half distance. A half of 8 is a 4, which means OK is 4 centimeters. Do we know VK? Do we know VK? We don't know VK. We only know VC, but we don't know VK. Now, we have this length. How about this length here? Who can remind us? Was it 17? Was it 17? No, 17 was for SC. Was it 8.5? 8.5 was this OC. Remember, we got 12 squared minus 8.5 squared. I'm sure you wrote it down somewhere. If you don't remember, we can go ahead and get it out. Remember, we said it was 12 squared, take away or minus 8.5 squared, which gave us, I remember it was 8.47. Now, if it was 8.47, that was our height. 8.47. But now the examiner does not want us to find the length VK. The examiner does not want us to find the length VK. The examiner is now interested in the angle theta. How do we get the angle theta? We are going to use what we call a mnemonic. 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 A mnemonic. A mnemonic. A mnemonic is a learning technique that we use to retain information as well as retrieve information, or to help us store information in our brains at the same time to remember it. For example, you used to say, I remember in physics, you say Roig Biv, where you have Richard of York gave birth in vain, where you have red, orange, yellow, green, blue, indigo, and violet, the colors of the rainbow. We can have another mnemonic. Superman helps everyone. Superman helps everyone. Superior, Michigan, Huron, Erie, Ontario. The lakes of the Great Lakes region. Another mnemonic can be, we can talk of my very excellent mother just sent us 9 potatoes. My very excellent mother just sent us 9 potatoes for the quarantine period. Only 9 potatoes. What does this help us to remember? It helps us to remember the planets of the solar system, where you have Mars, Venus, Earth. This is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. I'm sure people must be happy out there. These are what we call mnemonics. A mnemonic that is directly going to help us in this question. And that mnemonic is SOHCAHTOA. I can hear some people say it. SOHCAHTOA, where we have sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. We are going to see which one of the 3 is going to help us to find the angle theta. Finding the angle theta. Now, if this is a theta, this is our adjacent, this is our opposite or the height, and this is our hypotenuse. Whenever we are using this mnemonic, this formula, we need to be having at least 2 known values. Remember, we have 1, 2, 3. 2 of them must be known. 1, 2, 3. 2 of them must be known. 1, 2, 3. 2 of them must be known. In case you have 2 which are not known, it means that formula cannot help us. Let us start. If this is our angle theta, we have the opposite. The opposite is 8.47. Do we know it? Yes, we know it is 8.47. Now, opposite. Wherever there is opposite, we tick. Opposite, yes. Opposite, yes. Good. We have adjacent. Do we have adjacent? Yes. Wherever we have adjacent, we tick. Adjacent, yes. Adjacent, yes. We continue. We are moving together. This is Obonyo Kenneth on Google the TV e-learning project Trinity SS Navoiru. Now, this is our hypotenuse. Do we have the hypotenuse? Hypotenuse? Viewers, do you have the hypotenuse there? Me, mine is not there. The cameraman, do you have yours? All of us don't have. The hypotenuse is missing. It is not there. We don't have it. It is not known, which means where there is H, hypotenuse, you don't have. We don't have you. Here we don't have hypotenuse. Now what do we do? But again, we are looking for theta. we are looking for the angle which is represented by either a sine, a cosine, or a tangent, which means we also don't know it because it is the one we are looking for. So which means sine, we don't know. Cosine, we don't know. Tangent, we don't know. Because all of those are representing the angle. Now, which one of these three has 2 ticks? Which one of those three has 2 ticks? This first one? No. It has only 1 tick. The second one? No. Some of you are going to miss supper today because you're giving us wrong answers. The last one? Yes. Here we have 2 ticks, which means we are going to use TOA. Mr. Examiner, sir, using tan. Tan what? Theta, which is equivalent to what? O, representing the opposite. Opposite. Over A. A standing for the adjacent. Tan theta will equal to the opposite. But what is the opposite? It is 8.47 out of the adjacent, which is a what? A 4 centimeters. That is still our tan theta. Tan theta. But Mr. Examiner, sir, our interest is not tan theta. Our interest is to find the value of theta. We want theta. We want to make theta the subject of the formula. In making theta the subject of the formula, we are going to remove this tan from the left-hand side to shift to the right-hand side, so that we have theta equaling to the arctan or tan inverse of this fraction 8.47 all over or out of 4. That is what we have now. Viewers, let us get some space. I know some people feel like finishing the number. Some are saying the number is too long. It is not long. Just because I've spent some time while explaining, it doesn't make the number to be long. This is a very short number. Mr. Examiner, sir, we are almost coming to your final answer. I know you're waiting with your ready pen to mark. Theta, Mr. Examiner, sir, will equal to, now here we need to use a calculator or logbooks. But for now, let us use a calculator. We need to go to shift tan. In a bracket, we are having a fraction 8.47. The denominator is a 4. When we close the bracket, we are having 64.72. So which means we have 64.72. Is it centimeters? No, it is not. Is it kilometers? No, it is an angle which is being measured in degrees. Mr. Examiner, sir, this brings us to our angle. The angle we were looking for was the angle between the plane V, B, C, and its base. We can even conclude by saying, Mr. Examiner, sir, hence the angle between planes VBC and ABCD is 64.72 degrees. And that becomes our final answer. Let us go for a short break and eat something small, take some little water, and then ensure that we have sanitized our hands, and then we shall be back for part C of this question. You're viewing Obonyo Kenneth on Google the TV e-learning teachers project.